10. Instrumentation and Control Interview Questions, Part 1. Intro. Hi, welcome to Insights and Motivation YouTube channel, where I cover everything related to instrumentation, automation, and control in design engineering, automation, and implementation during the concept, feed, and EPC stages of projects, along with project management aspects during engineering. I bring in my 30-plus years of experience working across the Middle East, and from engineering consultants and automation vendors to major oil companies as a project management consultant. Through this medium, I want to inspire and educate young engineers stepping into the industry. There's also a playlist titled How to Be a Good Professional to help you enhance your soft skill set. Let me begin. What is the difference between a transducer and a transmitter? A transducer converts one form of energy into another, for example, pressure into an electrical signal. A transmitter conditions that signal and sends it over a distance, typically as a 420 milliamps or digital heart field bus signal. Every transmitter contains a transducer, but not every transducer is a transmitter. Why do industries prefer 420 milliamps over 0 to 10 volt signals? Because the 420 milliamp current loop is noise immune, reliable over long cable runs, and allows a live 4 milliamps that distinguishes normal operation from a cable break or power loss. It's the backbone of analog instrumentation worldwide. What does a control valve positioner do? A valve positioner ensures the valve stem reaches the exact position commanded by the controller. It compensates for friction, spring hysteresis, and air pressure variations, giving precise control. Smart positioners also provide digital communication, self-calibration, and diagnostics. How do you calibrate a pressure transmitter in the field? 1. Isolate the transmitter from the process. 2. Connect a pressure calibrator or dead weight tester. Apply known pressures step by step. 4. Adjust zero and span to align readings. 5. Record as found and as left data for QA/QC. This is a standard EPC site procedure. What's the difference between open loop and closed loop control? Open loop, no feedback. The system doesn't compare output with the set point, e.g. manual pump start. Closed loop, feedback continuously adjusts the output using a P&ID controller, ensuring stability and accuracy. Instrumentation engineers mainly design and tune closed loop systems. What is 3-element control in boiler drum level systems? It uses 3 inputs, drum level, steam flow, and feed water flow, to stabilize level during load changes. This compensates for shrink and swell effects, ensuring safe, steady boiler operation. How do you select the right thermocouple type for an application? Selection depends on temperature range, environment, and accuracy. Type K, general purpose, up to 1260 degrees Celsius. Type J, low temperature, to 760 degrees Celsius. Type RS, high temp furnaces. Type T, cryogenic service. Always check chemical compatibility and electromagnetic noise conditions before finalizing. What is the role of a manifold in differential pressure transmitters? A 3 or 5 valve manifold enables safe isolation, equalization, and venting during calibration or maintenance. It protects diaphragms from overpressure and ensures accurate, repeatable readings. What's the difference between intrinsically safe IS and explosion-proof EXD protection? Intrinsic safety, IS, limits circuit energy so ignition can't occur even in explosive gas. Explosion-proof XD contains internal explosions within a flame-tight enclosure. IS is used for low-power instrument loops, XD for higher-power field devices. How do interlocks differ from trips and control logic? An interlock prevents unsafe operation. It's preventive logic. A trip shuts equipment down after a fault. It's protective logic. Both form critical layers in a safety instrumented system, SIS, for plant protection. End of Part 1. Stay tuned for Part 2, where we'll explore more advanced instrumentation and control interview questions and practical project scenarios. Header 10, Instrumentation and Control Interview Questions, Part 2. Intro. Hi. Welcome back to Insights and Motivation, your channel for instrumentation, automation, and control insights, covering every stage of the project lifecycle: concept, feed, EPC, and commissioning, plus project management perspectives from real industry experience. With over 30 years in the Middle East oil and gas sector, I've worked across engineering consultants, automation vendors, and oil companies. And through this medium, I want to help young engineers grow technically and professionally. If you've not watched Part 1 yet, check it out. We covered the fundamentals. Now let's go a little deeper into practical and conceptual questions you're likely to face in EPC interviews and site discussions. What is the difference between a 2-wire and a 4-wire transmitter? 2-wire transmitters get both power and signal through the same loop, typically a 4 to 20 milliamps current loop. 4-wire transmitters have separate pairs for power and signal, used when high power or high load drives are needed. 2-wire designs are common for field loops, while 4-wire models are used for analyzers, ultrasonic sensors, or remote I/O. How do you differentiate between smart and conventional transmitters? A smart transmitter includes a microprocessor that handles signal linearization, temperature compensation, and digital communication via HART, Fieldbus, or Profibus. A conventional analog transmitter only outputs a raw 4 to 20 milliamp signal proportional to process variable with no digital diagnostics or configuration options. What is a 2003 2 out of 3 voting logic, and where is it used? 2003 voting is used in safety instrumented systems, IS, to ensure both reliability and availability. Out of 3 sensors, the logic takes the common result of any 2. It tolerates one sensor failure without triggering a false trip, common in critical trip systems like compressors, furnaces, or reactor shutdowns. Explain what is meant by rangeability, or turn-down ratio of a transmitter. It's the ratio between the maximum measurable range and the minimum measurable range with acceptable accuracy. For example, a turn-down ratio of 100:1 means a transmitter can accurately measure from 1% to 100% of its range. Smart transmitters typically allow higher turn-down via digital scaling. What is the difference between gauge pressure, absolute pressure, and differential pressure? Gauge pressure, PG, measured relative to atmospheric pressure. Absolute pressure, PA, measured relative to a perfect vacuum. Differential pressure, PD, the difference between 2 pressure points. Most process transmitters measure differential pressure, and the same sensor design is adapted for flow, level, or filter monitoring. How do you measure flow using a differential pressure transmitter? You use a primary element like orifice plate, venturi, or pit-out tube that creates a pressure drop proportional to the square of the flow rate. The DP transmitter measures this differential and converts it into a linear flow signal through square root extraction. Modern systems perform this extraction in the DCS or PLC logic for flexibility. What are the main components of a typical control loop? 1. Sensor, transmitter, measures process variable, e.g. pressure. 2. Controller, compares measured value to set point, computes corrective action, P&ID. 3. Final control element, typically a control valve or VFD motor that changes the process condition. This triad forms the backbone of process automation. Measure, decide, act. What is the function of a position feedback transmitter on a control valve? It provides an independent feedback signal, 4 to 20 milliamps, representing the valve stem position. It's essential when the control system needs redundant position feedback, remote diagnostics, or partial stroke testing in safety systems. In SIL-rated loops, it's part of proof test validation and valve performance tracking. How do you perform loop checking during commissioning? Verify cable continuity and terminations. Simulate process inputs via hand pump or calibrator. Confirm correct signal reading at marshalling panels, DCS, and HMI. Check control action, for example, increase input valve opens, direct inverse, validate alarms, trips, and interlocks. Loop checking ensures every field instrument communicates correctly through the control chain. What are the main differences between PLC, DCS, and SCADA systems? Parameter, PLC, DCS, SCADA. Purpose, discrete logic control, continuous process control, remote monitoring and control. Architecture, centralized, fast scan, distributed multi-controller, wide area communication. Application, package units, skids, plants, refineries, pipelines, utilities, programming, ladder logic, function blocks, database, plus HMI graphics, DFRX. In modern projects, all 3 often integrate through Ethernet IP, Modbus, or OPC UA, forming one connected control ecosystem. End of Part 2. In Part 3, we'll move into advanced level instrumentation questions, covering field bus systems, control philosophies, and project documentation standards, like P&IDs, IO lists, and logic narratives. 10. Implementation and control interview questions, Part 3, advanced level. Intro. Hi, welcome again to Insights and Motivation, your go-to channel for mastering instrumentation, automation, and control across the full project cycle, from concept and feed through EPC, commissioning, and project management. I'm sharing insights from my 30-plus years of experience in the Middle East oil and gas sector, where I've worked with consultants, automation vendors, and oil companies as a project management consultant. In this third part, let's raise the technical depth a notch, focusing on advanced interview questions that test your understanding of instrumentation networks, documentation, control logic, and system integration. What are the major differences between HART, Foundation Field Bus, and Profibus PA? Parameter, HART, Profibus PA, and signal type, analog plus digital overlay on 420 milliamp, fully digital. Communication speed, EPC 1.2 kbps, 31.25 kbps, 31.2 piece. Power supply, loop powered, bus powered. Topology, point-to-point bus topology. Control location, host-based, field or host-based. HART is ideal for hybrid analog digital systems, while Fieldbus and Profibus PA suit full digital control architectures used in modern DCS networks. What is a P&ID and how does it differ from a loop diagram? A P&ID, piping and instrumentation diagram, shows the overall process scheme, instrumentation connections, and control logic at the system level. A loop diagram zooms in on one particular control loop, showing terminal numbers, cable tags, junction boxes, marshalling panels, and I/O cards. In short, P&ID equals what is controlled. Loop diagram equals how it is controlled. Explain what a cause and effect C&E diagram is used for. A C&E diagram defines the logical relationship between causes, like alarms, trips, or field conditions, and their corresponding effects, like shutdowns or activations. It's vital in safety instrumented systems and emergency shutdown (ESD) logic validation. During FAT or SAT, engineers simulate cause conditions to verify if the intended effects occur correctly. What is safety integrity level and how is it determined? CL represents the reliability level of a safety instrumented function, SIF, from SIL 1, basic protection, to SIL 4, highest integrity. It's determined through a LOPA, layer of protection analysis, based on probability of failure on demand, PFD, risk reduction factor, RRF, consequence severity, and frequency. For example, SIL 2 is typical in refineries and process industries for shutdown and ESD systems. What are the key deliverables of the instrumentation discipline during the feed stage? Typical feed deliverables include instrument index, I/O list, P&IDs with control philosophy, typical loop diagrams, preliminary instrument data sheets, cable block diagrams, control system architecture drawings. These form the basis of EPC stage detailed design, vendor inquiries, and budget estimation. How do you perform an I/O assignment and what are the key considerations? During I/O assignment, map every instrument tag from the I/O list to a specific DCS or PLC card. Maintain segregation between analog input-output, digital input-output, and pulse signals. Follow redundancy and marshalling layout rules. Keep SIS/IO isolated from BPCS/IO. Proper assignment ensures ease of maintenance, scalability, and system integrity during commissioning. What is the purpose of using isolators and signal converters in control systems? Signal isolators prevent ground loops and electrical noise by galvanically isolating input and output. Signal converters translate between formats, e.g. RTD 420 milliamps or 420 milliamps 1 to 5 volts. They improve system reliability, protect equipment, and ensure accurate signal transmission between different grounding zones. How do you determine the orifice plate size for flow measurement? Sizing involves process parameters, density, viscosity, flow range, line size. Required beta ratio, ratio of orifice bore to pipe ID, typically 0.4 to 0.75, Reynolds number to ensure flow regime validity, pressure drop limits, and ISO 5167 standard calculations. In practice, EPC engineers use flow calculation software or vendor tools like Emerson's FlowPro or ABB sizing programs. Explain the concept of redundancy in control systems. Redundancy ensures reliability by providing backup for critical components. Types include controller redundancy, 102, 203, power supply redundancy, I/O redundancy, network redundancy, dual ring or star topology. This ensures zero downtime even if one module fails. a must for critical oil and gas and refinery systems. What are the key steps during a FAT, factory acceptance test, for a DCS system? 1. Verify I/O simulation for all configured points. 2. Test control logic, P&ID interlocks, trips. 3. Check alarm, event, and graphics displays. 4. Review C&E logic implementation. 5. Validate reports and historian interfaces. 6. Document deviations and punch lists for closure before shipment. A FAT ensures that the control system performs exactly as per design before installation on site. End of Part 3. In Part 4, we'll explore real project case-based interview questions covering loop tuning, advanced diagnostics, field commissioning, and control narratives, helping you prepare like a professional for EPC and PMC roles. Would you like me to continue to Part 4, focusing on case-based and problem-solving questions that simulate real commissioning or troubleshooting scenarios, ideal for senior-level interviews?